Hey, Palmerettis. It is Wednesday, April 15th. It's our second lesson of math, second lesson of science this week. Hopefully you're getting everything turned in. We will have a Wednesday chat video coming up here for you, and then we'll have a science video. So 3 videos for today. I want to walk through topic 1, math 14.1, colored pages 521, 523, homework page 177. We're going to walk through these pages. This homework assignment will be due Thursday, April 16th. By 3 o'clock would be great, but if it's later than that, that's fine that day. That's great. Just trying to keep you guys on deadlines. Again, we're here to help you, so reach out, guys. We miss you. Okay? All right, so this chapter, and I'm telling you right now, this is a good chapter. Number sequences. This is where we're going to see patterns. We're going to talk rules and patterns and different things like that. So stay with me. Let's walk through it. So it says, look at the rules and starting numbers below. What are the next 6 numbers in each pattern? Okay. Tell how you decide to describe features. This is going to be the toughest part for us, describing the features. When we describe the features, we can say, oh, we were counting by 2s, we were counting by 3s, we were counting by 7s. We had multiples of 6 or multiples of 9 or multiples of 8. You could sit there and say, hey, all the numbers are odd, all the numbers are even. So when we're describing the features, that's just another part we can do. So we can find the next numbers, but we can also describe them. Let's do some examples of this. This is where you might need some lined paper, so have some lined paper ready to go if you don't have enough room. So the first one says we're going to start with 18. Add 3. 18 plus 3. 21. 21 plus 3. 24. 24 plus 3. 27. 27 plus 3. 30. 30 plus 3. 33. 33 plus 3. 36. 1, 2, 3, 4, 5, 6. There go our next 6 numbers. Now, Mr. Coletti, do we have to show our work? Well, I'd like you to. Mr. Coletti, I can count by it in my head. Absolutely. But all of us have shown that our brains, if we just do it in our brains, sometimes our mental side of it is going to fail us, so that's why we show our work. Now let's talk about what you see here. What can we talk about them? Are they all even? No. Are they all odd? No. Well, some are even and some are odd. That's kind of not a really good description, but what you could say is for this one, they're all multiples of 3. Very simple. Describe it. Well, we skip counting by 3s. We did multiples of 3. Very good. 17 add 2. 17 plus 2. 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 27, 28, 29. 1, 2, 3, 4, 5, 6. What do we see there? Well, let's talk about them. They're all skip counting by 2s, but they're all odd numbers. See that? So a couple things. We could say that they're all even, they're all odd. We could sit there and say we were skip counting or doing multiples of 2. Next one says 40 minus 4. Now, this one is not as easy. If I did it in my head, I could sit there and go 40, 39, 38, 37, 36. I could do that. And a lot of you like to use your fingers, and that's fine. But again, being able to show our work. Okay, 36. Now, should these numbers when we're subtracting increase or decrease? That's the other conversation we could have. They're going to decrease because we're subtracting. 36 minus 4, 32. 32 minus 4, we got to do a little regrouping here. 28. 28 minus 4, 24. 24 minus 4, 20. 20 minus 4, a little regrouping, 16. 36, 32, 28, 24, 20, 16, 1, 2, 3, 4, 5, 6. The first, second, third, fourth, fifth, sixth numbers. What can we say about all those? They're all even. So what I would suggest in the describing the features, either tell me that they're all even, tell me that they're all odd, or tell me that they're multiples or we're skip counting by a certain number. Okay? You could sit there and create your own 2 patterns that you use the same rule but start with different numbers. Identify a feature of each pattern, for example. That one I'm not going to too worry about it. We're not going to stress about it. There's a bunch in here that we can do for EP problems, so you can work on that one on your own. All right, that's page 521. Let's look over at 522. And again, a good example here. The house numbers on a street follow the rule. Here's our rule. We're going to add 4. And if the pattern continues, what are the next three house numbers? Well, 16 plus 4, 20. 20 plus 4, 24. 24 plus 4, 28. What does that look like? Absolutely, it looks like a number line, right? So in this number line, we're just going to be doing by skip counting multiples. It's not multiples. We're skip counting by 4, okay? We could say they are multiples of 4, or we're skip counting by 4. So either way you want to describe it. A rule is a mathematical phrase. Here's a definition. A rule is a mathematical phrase that tells how numbers of shapes in a pattern are related. So again, there's our work. There's our number line. There's our skip counting. There are our multiples of 4. All right? Can you use the rule add 4 to create a different pattern with all odd numbers? Well, can you means I'm asking you yes or no. So if I sit there and say, all right, give me a different pattern, but can it be all odd numbers? Yeah, the answer is yes, right? So give me an odd number, right? So if we say, all right, 3 plus 4 is 7, plus 4 is 11, right? Plus 4 is 15. There goes a pattern, right? All right, so let's go on. 523. Another example. I love this. Again, there's one thing I've said about this all year, guys. I really love the fact that they give us examples, okay? On another street, the house numbers follow the rule. Subtract 5. What are the next three house numbers after 825? So 825 minus 5. Minus 5, minus 5. Again, they didn't show their work. That's the only thing that I would get on them about is that they didn't show their work. Show your work. Do you understand? Rudy's rule is add 2. He started with 4 and wrote the numbers below. Which number? Now here's where they're going to flip the switch on you guys. Now they're going to ask you to look at it a different way. Which one does not belong to Rudy's pattern? So he said we're going to add 2. What's 4 plus 2? 6. Plus 2. 8. Plus 2, 10, plus 2, 12. The number that does not belong is the 9. The 9 is not going to work there. Okay, so again, explaining to me that 4 plus 2 is 6. 6 plus 2 is 8, right? 8 plus 2 would be 10, and so forth, right? Okay, continue the pattern. Describe a feature of the pattern. This right here is where we're going to add a description, okay? Now we're going to add something to it. We're not only going to figure out the next numbers, but we're going to add a description. 48 minus 6 is 42. Minus 6 is 36. Minus 6 is 30. Minus 6 is 24. Now, 24 minus 6. I'm going to do it on my line paper over here. Here's my regrouping, and I'm going to get 18. 18 minus 6. Watch this. I could do it right underneath if I wanted. 12 minus 6 is 6. See that? Now, as you look at 48, 42, 36, 30, 24, 18, 12, 6, what could you say about them? Are they all multiples of 6? Absolutely, right? Could you say that they're all even? Absolutely. So you could say that they're multiples of 6. You could say that they're all even. These are ways to describe it. That's the challenging part here. How would you describe them? Figuring out using adding or subtracting or multiplying or dividing, that goes back to your basic math facts, guys, and you're showing your work. Being able to tell me, are they multiples of whatever number they are, or are they all even or all odd? Now we're going to add that to it, all odd. All right? Continue each pattern, describe a feature of each pattern. Okay? So they want you to finish it and then put a description underneath it. Okay? All right, so let's talk about it. Subtract 3. There's our step. 63 minus 3, minus 3. Well, minus 3, 54. Minus 3, 51. Bang, you're done, right? Are we allowed to do that, Mr. Coletti? Is it showing your work? Absolutely. I didn't have to use my paper. Now look at those. Tell me about 63, 60, 57, 54, and 51. Are they all even? Nope. Are they all odd? Nope. So now that's where you've got to get it. Well, if we're going by 3, they're all multiples of 3. There's your description. Okay? Down here, let's do this one. Add 7, right? Add 25. Subtract 4. So you've got multiples of 25, multiples of 4, multiples of 7. You know what? Actually, I just said multiples of 25. That's not going to work here. Forgive me on that one. Not going to work here. Subtracting the 4, not going to work here. So we can't say that those are multiples. That is my error, my mistake. Rewind that, rephrase it. Let's look at this one here. 444, 451, 458. All right, this one's now we could say the numbers alternate. Even, odd, even, odd, even, odd. For number 6, we could say that they're all odd, right? So let's do this work, and we'll do it here. So 444 minus 7 is 451. 458 minus 7 is, okay, I got to stop here because I'm racing on myself. Add 7. 451 plus 7. 458 plus 7. I'm going to do my line paper here. 458 plus 7. And if I just confused you over this last little bit, pause it, rewind it, and then text me and say, man, slow down, Mr. Coletti. 465. I'm going to add 7 to that. 472. Okay, so as we look at this one here, even, odd, even, odd, even, odd. It alternates. Even, odd, even, odd. That is something you can explain right there, that it alternates. That's another way that we can say it. Okay? Go down here to adding 25. 85 plus 25, 110 plus 25, 135 plus 25. 5 and 5, 3, 2, and the 1 is 6. We get 160. 160 plus 25, we get 185. So these are all not multiples of 25. They're not all multiples of 7. We've got to be careful with that. That's one thing we have to do right here. But they are all multiples of 5. Go back to when we talked about when we could sit there and break down numbers. If you look here, we see a 5, 5, 0, 5, 0, 5, right? We talk about those numbers as far as dividing. We can divide them by a 5 or a 0. So they are all multiples of 5. Put a star by that one now, right there. 5, I want you to review. 6, subtract 4. 75 minus 4, 71 minus 4, 67 minus 4. 63 minus 4. Got to regroup. 59. Now, when you look at all those numbers, what can you tell me about all those? Yeah, these are all odd. So there's different ways that we can explain these numbers. It's just finding them out, okay? I'm going to put a big old EP down here, all right? You can work on these ones here. Subtracting 10, adding 107, adding 51, subtracting 15, adding 5, subtracting 19. Work on those on your in-between days, your Tuesdays and Thursdays, just to stay sharp, all right? Let's flip that page over. All right, let's tackle this last page here. What are we doing on time? 12, 13 minutes? Good. Then we'll get into the homework page. Orlando delivers mail. He sees one mailbox that does not have a number. If the numbers are in a pattern, what is the missing number? 27 to 29. We don't have a number here. 33 to 35 to 37 to 39. Do you see the pattern? Well, how does 27 become 29? Is it increasing or decreasing? Increasing. So are we adding, subtracting, multiplying, or dividing? Adding. So add 2. So 29 plus 2, 31 plus 2 would be 33, 35, and that works, okay? Now 14, okay? 14 is an old school problem. A bus tour runs 9 times a day, 6 days a week. The bus can carry 30 passengers. Find the greatest number of passengers who can ride the tour bus. So when we look at that problem, all right, the first thing we see is 9 times 6, and what do you get? I've told you earlier, that's my toughest math problem. I have to review that one every day. So 54 times a day, 9 times a day for 6 days a week. They do 54 bus tours. They get 30 on each one. Now, a couple ways we can do this one. You could do 54 times 3 and then plug in a 0, or you can go with your box method, right? Now, parents, students, we did not get, what did I say, 54 times 30? We did not get to doing two-digit multiplication old school, so if you want to teach them that, that's fine. I'm going to hopefully get that taught to them by that time. So I don't need this second box. So 50 times 30, 15, 2 zeros, 1,500. 30 times 4, 3 times 4 is 12. Plug in the 0, so you have 1,500 plus 120. We get 1,620 passengers. Okay? Now, if you want to do 54 times 3, you're still going to get 162, but then you got to plug in that 0. You're still going to get the same answer. All right, so 1,620 is our final answer. All right? Okay. Now, number 15 takes us back to this lesson. The year 2017 was the year of the rooster of the Chinese on the Chinese calendar. The next year of the rooster will be 2029. The rule is add 12. So what are the next 5 years? So we're just going to keep adding 12. So 2029, 2029 plus 12. Yep, 9 and 2, 2, 1 and 1, 2041. Add 12. 2053. Okay? Add 12. 2065. I'm going to stop right there. I think you guys get the idea behind it. Now, to describe a feature of the rooster pattern, that's what we want to describe it. Are they all odd? Are they all even? Are they alternating odd and even? All right? What are they multiples of? Now, figuring out the multiples here, now you're going to challenge yourself. So I would go with a simple description. They're all odd. They're all odd, right? Okay. Number 17 says, define the rule, create a number pattern using the rule, subtract 7. All right, so we could sit there and start with any number we wanted, right? I wouldn't start with 7 because then we would just land on 0. So subtracting 7, you could do something like 77. Minus 7 would be 70. Minus 7 would be 63. Minus 7 would be 56, right? So you would just want to do your work and create your rule. Did they say to describe it? Nope, they just want you to create the rule. You with me on that one? All right, good deal. Some patterns, this one right here, put a star right here. Some patterns use both addition and subtraction in their rules. This one is, hey, we're going to add 3, subtract 2. This is some of my favorite math right here. Add 3, subtract 2, find the next 3 numbers. So add 3, we get 4. Subtract 2, we get 2. Add 3, we get 5. Subtract 2, we get 3. Add 3, we get 6. Minus the 2, we get 4. Add 3, we get 7. So you want to alternate. Add, subtract, add, subtract, add, subtract. So what's 7 plus 3? Yeah, 10. 10 minus 2, 8. 8 plus 3, 11. So play around with that one right here, okay? All right? And, oh, man, they're going to sit down here and break this down a few different ways. So add 3, subtract 2. I'm going to work something out here real quick because the answers they have in the book are different. And this is where I get really frustrated. This was a lesson that I've seen it. The way I've seen it on the computer and on iReady, I want you to talk to me if you see any of these come up and tell me how they look. Are they like this? Are they alternating it? Sometimes they want you to do it all at the same time. So what's 1 plus 3? 4 minus 2 is 2. So if we go 4 plus 3, that's 7 minus 2, that's 5. So I'm going to sit there and I'm going to email the lady again, because I think this is how we do it, but I'm going to check her out, and I'm going to email Miss Floss or Miss Foss about this one. So we're going to talk to her, and then I'll get back to you on that one. But go with that right there. Now, down here, Rima used subtract 3 as the rule to make a pattern. So there's our rule again, and there's going to be a pattern there. She started with 60. She's telling you what she started with, right? The next 6 numbers in her pattern, which number does not belong? So 60 minus 3. And I'm going to sit here, and I'm going to use my paper. 60 minus 3, right? We get 57. I see 57. 57 minus 3, 54. I see 54. Minus 3, 51. Okay, it's not over there, but I'm going to keep going. Minus 3, got to regroup here. I get 48. 48 minus 3, 45. I got 45. So process of eliminate, we do some PO there. Our answer is letter D, isn't it? Could I keep going? Absolutely. But since I've landed on those 3 for time purposes, I'm good. Ivan counted all the beans in a jar. If he counted the beans in groups of 6. So he's counting by 7s. Did I say groups of 6? Groups of 7s. Whew. So he's going by 7s. 77 plus 7, it's 84 plus 7, 91 plus, wait a minute, that's not going to work because that's by 8. 301 plus 7, 308 plus 7, 315. Plus 7, 322. Right there, it's not going to work. 74 plus 7 is 81. Plus 7 is 88. Plus 7, and that's going to work right there. From here to here is by 10. So you can find that. And again, process of eliminate, showing your work there, figuring it out, and that tackles that. All right? Now looking at your homework. Page 177, make sure you put your name on it. Number sequences, look at their examples. Okay, she's adding by 11. Combine it and then describe it, okay? So we're going to do one together. 30 minus 2, 28 minus 2 would be 24, minus 2 would be 22. Tell me about all those numbers. Okay, you could say that they're multiples of 3, or they're all even. Okay, you could say they're multiples. Did I say multiples of 3? Holy cow, guys. I'm losing my mind right now, aren't I? Multiples of 2. Come on, Mr. Coletti, get it together. So right there, what I want you to do is I want you to do 2, 4, and 6. Okay, do 2, 4, and 6. All right, got that? 2, 4, and 6. Make sure you describe underneath there. Describe the pattern. Are they all odd? Are they all even? Do they alternate? Are they multiples? What are they multiples of? Now use the rule to fill in the missing number in each pattern. So 41 plus 3 is 44 plus 3. 47 plus 3 is 50. All right, so I did that one here. I want you to do 10, 11, and 12. Look at 11 and 12 very carefully. For 11 and 12, okay, go back for 11 and 12. Go back to the number 18 right here, okay? So I'm going to put a little note here for you. See number 18 on 524. See number 18 on page 524 for these two, all right? So you only have 6 problems to do on the front, okay? All right. On the back. All right, make sense and persevere. This is a review problem, okay? So you're going to buy a sandwich, a salad, and a drink. So you're going to buy one of each of these. So you're buying all those. What is the cashier going to do? He or she is going to add them up. You have $20. How much change will you have? So get me that problem right there. You might need to use line paper or do it off to the side right here. Okay? Mimi started a pattern with 55 and used the rule add 10. What are the first 5 numbers in her pattern? 1, 2, 3, 4, 5. If she started with 55, right? Well, her first number is going to be 55. You do the next ones, okay? So you're going to do 13 and 14. Jack arranged the pencils in groups of 6. To make a pattern, his rule is add 6. Well, he had 6 pencils, right? Okay, so figure it out. If this is 6, what's going to come next? All right, skip count by 6s there. Okay, so you're doing 13, 14, and 15. 16 presidential elections are held every 4 years, right? So in 1840, 1844, 1848, 1852, every 4 years, what are they counting by? It's going to be by 4. What were the next 3 presidential elections? So give me the next 3. Okay? So just keep adding 4. Put a star by the number 17. Okay? Sarah created a pattern. Her rule was add 4. All the numbers in Sarah's pattern were odd. Okay? So they have to all be odd. 3 of the numbers are less than 10. So we're going to work this one out together, and we're going to check that one off. If we started with the number 0, if we add 4 and then add another 4, what do we have? They're all even. Not going to work. If we go with the 1, add 4, we'd get 5. Add 5, we'd get 9, right? Add 4, we'd get 13. Are they all odd? Yes. Are there 3 of them less than 10? Yes. So we would start with the number 1. That's your answer. If we did it by 2s, we would land on 6 and then 10. They're all even. Not going to work. If we did it by 3, we would go to 7. Add 4 would make 11. The problem is only 2 are less than 10. So that's not going to work. What we find out here is that this is the best way to go. Start with the 1, and then we could find the answer. Okay? All right. Number 18. The house numbers on Carr Memorial Avenue follow a pattern. The first 4 houses on the left side of the street are numbered 1,408, 1,414, 1,420, 1,426. The rule is they keep adding 6. How many more houses are on the left side of the street with numbers less than 150? Put a star by this one. 1,450. So keep adding by 4s. So do that on your paper here or on the line paper. And then how many more houses would be on that side of the street? That's going to be a tough one. Number 19. Noreen is training for a race. The first week she runs 54 minutes. Then the second week, 52. The third week, 50. Do you see what's happening? 54, 52, 50. She runs 2 minutes faster each week. Now, in a race, when we say faster, that means we want the lower numbers. So we see that we're subtracting by 2 here. We want to get the faster we go. So if you run a mile in 20 minutes, you want to run that mile the next time lower than that, 18 minutes. Then keep working it down until you get to your fastest mile. So that's the key here. So put a star by this one. If the pattern continues, how many minutes will it take her to run the route the 5th week? Okay, first week, she went 54. Second week, 52. The third week, 50. 54, 52, 50. First, second, third. To get to the fourth, get to the fifth. This is the answer I'm looking for right there. You with me? All right? So figure that one out. So on the back, you're going to do 13, 14, 15, 16, 18, and 19. That's 12 problems. 1, 2, 3, 4, 5, 6 on the back. 1, 2, 3, 4, 5, 6 on the front. All right, guys? This is Wednesday, April 15th. I'd like to have this Thursday afternoon by 3 p.m. on Thursday the 16th. All right? All right, guys. Keep an eye out for the science and the chat coming. Talk to you later.